Hello, ninth grade. This video is to remind us how we can find distances between our corresponding points. So I'm first going to draw a T like we did in class. Actually, move it over to the left a little bit. And now where I'm generally going to plot these points will create a triangle for us. So this first one, if we look at the original from the ankle to the hat, this is over 4 and up just a little bit. So this is 4, 1. I'm going to zoom in so you can see that graph. And then the other point is over about 3 points and up 7. And let's call each of these spaces 2. And so over just a little bit, 3, and then up to 7. And so when you draw this line, think about that triangle. So horizontally, between 3 and 4, there's only 1 space. But between 1 and 7, there are 6 spaces. So from the ankle to the right hat, ARH, or having that ratio, we are going to take the square root of 1 squared plus 6 squared, finding our hypotenuse. And when we do the order of operations, 6 squared plus 1 squared is the square root of 37. And I'm just going to call it ARH. And when we do that calculation, the square root of 37 is 6.08. Now let's keep looking at the other distance from the left hat to the spatula. So I'll call that L, the left hat to the spatula. But let's plot these points. So we need to go over about 5 spaces, so past this 4, but then up to 8. And label that at 5, 8. Then the second point at 7, 6. We need to go further out this way to 7, but up to 6. And notice this line. And now we need to create our triangle. Excuse me. So then looking from 5 to 7, we've gone 2 spaces horizontally. And then vertically, we've also gone 2 spaces. So we have 2 squared plus 2 squared. And so we take the square root of 2 squared plus 2 squared. 2 squared is 4. 2 squared is 4. 4 plus 4 is 8. And then when we take the square root, we get 2.83. Now let's keep going and look at the enlarged distances. So again, drawing our T. Move it over a little bit. Let's notice all of our points are positive. So I'm going to create more of an L shaped graph than a T. And then I'm going to space some of these pieces out. So I'm going to say that this is 10 and this is about 20. Just to create a picture so we can have our triangles. So this is 10 and 20. And then let's see, we need to go all the way up to 16. So let's see if we did this 2, 4, 6, 8, 10, 12, 14, 16. It will be enough. So we'll go up by 2s. And then I'm going to start with the ankle to the right hat. So we'll call that AR. The ankle to the right hat. So we need to go over 18, just before the 20, and then up 2. So that's 18 and 2. But then the right hat is at 16 and 14. So here would be about halfway. So here's 16 and then up to 14. That is in my way. So I'll do the work over here. And so that point is 16 and 14. I'm going to use my pencil to draw in this triangle. It's a very narrow triangle, but very tall. Notice that there are 2 spaces on the horizontal from 16 to 18. But then vertically, we start at 2 but go up to 14. So there's 12 spaces there. Remember, this is your enlarged figure, so we should expect big distances. So the ankle to the right hat will be equal to square root of 2 squared plus 12 squared. And then 2 squared is 4, 12 squared is 144. So that becomes the square root of 148, which is about 12.2. Now let's do the last one, the left hat to the spatula. Sorry. And the left hat is at 20, but up 16. So here's 20 and 16. But then we need to go a little bit more on our x-axis. And again, the point is just to get the triangle. So don't worry if it's messy. It's more just to be able to visualize where is the right triangle and what are the side lengths. So now we need to go up to 12 from that 24. 24 and 12 here, and then 20 and 16 there. And there is our hypotenuse, and here is the right triangle. If we notice 20 and 24, there are 4 spaces. And then 12 and 16, another 4 spaces. So we have an isosceles triangle here. And so from the left hat to the spatula, we get the square root of 4 squared plus 4 squared, which becomes 16 plus 16. And then we need to take the square root of 32. And what we get is about 18.1 there. Okay, so what we should be able to do from here is look at um, how these values compare to each other. And so if we looked at the original distance, so if we looked at specifically the distance from, I'm going to highlight these lines. And so if we looked at from the ankle to the right hat, we're looking at these two distances. And if they are enlarged, they should be according to our scale factor. And I had claimed that our scale factor was 2, as in 2 times the original size. And so that should mean that all corresponding sides are twice as big. So when we look at, when we look at the ankle to the right hand, or the right hat, excuse me, the right side of the hat, we get 6.08. And then when we look at the distance in the larger figure, the enlarged Bitmoji, we get 12.2. Just comparing the smaller, or the original, to the large. And we can see that it is about half. And so that confirms our relationship. And then you could go further and look at the other corresponding lengths, and also look at the distance in the reduced. The reduced should be half the length of the original. Thank you for watching this video.